as you continue in math. So I know the formulas that end up coming up in Calc 2 and Calc 3 that we use a lot. And we talked to Ms. Hine about the formulas that come up in Calc 1 and Calc 2 again. And we try to emphasize those formulas. So we're going to talk about the double angle and half angle formulas. So the double angle formulas are probably, I'm going to say they're a little more applicable. You see them a little more. But the half angle formulas is good to have seen them and know that they actually come from the double angle formulas. All right, so let's start with our sum formula for sine. So sine of u plus v is sine u cosine v plus sine v cosine v. And we want to put the same angle in here twice. So sine of u plus u, and that's the same as the sine of 2u. And I'm going to put the same angle here twice. So I get sine u cosine u plus sine u cosine u. And that equals, we have two of these, so that's 2 sine u cosine u. So our first double angle formula, sine of 2u equals 2 sine u cosine u. This is the one formula from today that I'm going to ask you to memorize. This one comes up a lot, and it's pretty easy, but this one I want you to memorize. So it comes from our sine sum formula. We're just putting the same angle in there twice. And we're going to do the same thing for the cosine formula, and then the tangent formula comes from doing the sine over the cosine. So the cosine of u plus v, just to remember our formula, is cosine u cosine v minus sine u sine v. And I want to plug the same angle in there twice, u plus u, which is cosine of 2u. And we get cosine u minus sine u sine u. So that tells us that cosine of 2u is cosine squared u minus sine squared u. So that's our second double angle formula. And this comes from our sum formula for cosine. And then don't we have a couple of Pythagorean identities that we could substitute either for cosine squared or sine squared and write this only with sines or cosines? We could plug in our Pythagorean identity for cosine squared or plug in our Pythagorean identity for sine squared. So we can do that and come up with two different equivalent identities for cosine 2u. So we can plug in and write it only in terms of cosines. So I get 2 cosine squared u minus 1 if I substitute for sine squared u. And I could substitute for cosine squared u, and I get the cosine of 2u equals 1 minus 2 sine squared u. So all of these, I would give you all of these formulas, all of these for your cosine double angle formulas. I'll give you all those for that. They're all equivalent. It just depends on what you have and what you're looking for which one you would use. These two we in Calc 3, we use these a lot in Calc 3. So they do come up a lot. These two more than this one, and this one does come up a lot as well. All right, so these all come from our our angle sum formulas, sum formulas for cosine and sine. And then to find tangent of 2u, we would just put the sine of 2u over the cosine of 2u and simplify. So our tangent sum formula, or sorry, our double angle formula for tangent of 2u equals 2 tangent u over 1 minus tangent squared. And I would provide you with that one as well. So what I'm going to do during the test, I'll just have a list of formulas written on the board. And again, this one comes from doing the sine of 2u over the cosine of 2u and simplifying. That's where this one comes from. Yes?
You only have to remember the top one.
The very top one, yep, from today. All right, so what I want to do is look at a couple of examples of how we would use these in a couple different places. And then we'll talk about our half angle formulas, show how the half angle formulas come from these equations, these two equations. So really we're just rearranging these a little bit to get our half angle formulas. And then we'll be done with chapter 5. All right, questions on where our formulas come from? All right, so let's look at a couple of examples. Let's solve cosine, do I want cosine sine of 2x minus cosine x equals 0. So the techniques that we've used before aren't going to work here because we have a sine of 2x and a cosine of x. We don't have, if they were both 2x's, then we'd be okay. If they were both 1x's, we'd be okay. But because they're mixed, we can't do what we've done before. But we remember, we say, oh, we have a formula for sine of 2x. So let's substitute that formula. Sine of 2x is 2 sine x cosine x minus cosine x equals 0. That looks a little better. So what do we do next to solve this equation? We have all of our trig functions on one side of the equation. Huh? What do we do? We got to do something. What do we do, Brandon? We already have all of our trig functions on one side, so that's good. So that would be our first step, is to get all our trig functions on one side. What do we want to do, Mary? Factor. We have a common term of cosine x. So let's factor that out. Cosine x times 2 sine x minus 1 equals 0. Now that looks better, right? So this tells us that the cosine of x equals 0, or 2 sine x minus 1 equals 0, so sine x equals 1/2. This has to be 0, or this has to be 0. Cosine x equals 0, so x equals, when is cosine 0? What is it? Pi over 2. That's one of them. Plus 2n pi. And where's the other one? We're at the positive y-axis. And 3 pi over 2. Negative y-axis plus 2n pi. Gives me a cosine of 0. And for sine of x equals 1/2, x equals small side of our 30, 60, 90 triangle. Pi over 6. And where's our other one? So we're here, we're positive, we want to be positive, so we go from the first quadrant over to the second quadrant, and that's going to give us 5 pi over 6. And then we have our solutions. And that one we substituted one of our formulas for sine 2x. Yeah. Added the 1 and divided by 2, exactly. All right, questions? Everybody good there? All right. Hopefully this next one, before we do the next problem, I have a joke for you guys. A trigonometry joke. Why did this formula, when it went to the bank, why could this formula not get a loan? Because it needed a cosigner. Okay. All right. Next example. Hopefully this one will be familiar now. We know that sine of x equals 12/13 and pi over 2 less than or equal to x less than or equal to pi. And we want to find sine of 2x, cosine 2x, and tangent 2x. All right, so we're looking for all of these double angle things. So I'm going to, let me just write some formulas over here. We know that sine of 2x equals 2 sine x cosine x. I need cosine x. I have sine x. How do I find cosine x? Using this information. Yes. Draw a triangle. You can draw a triangle here, find cosine x. I'm going to say that cosine 2x, let's use our identity that only uses sine x. Cosine 2x is 1 minus 2 sine squared x. So I can find that directly from here. I could use the other one, one of the other identities as well, because we have to find cosine x. But this one would be easy to use. And on these kinds of problems, I'm going to say, usually it's easier to say tangent 2x equals sine of 2x over cosine of 2x rather than using the formula. So unless the problem specifically asks you to use the formula, you can always say that the tangent of the angle is just a sine over the cosine. All right, so let's draw our triangle. Pi over 2 is less than or equal to x less than or equal to pi. What does that tell us about this problem? Where's our angle? Quadrant 2. We're between pi over 2 and pi, so that tells us our angle is over here. So that tells us draw our triangle in quadrant 2. So here's my triangle in quadrant 2. And there's x. Sine is 12 over 13. On this triangle, what is this side going to be? Negative 5. We could use a Pythagorean theorem to find that if we didn't remember that's a Pythagorean triple. And it's negative because we're in quadrant 2. So the x coordinate is going to be negative. So cosine x is going to be negative 5/13 from our triangle. And now we have everything we need. All we needed was cosine x, and we're set to find all of these things that we're looking for. So sine of 2x equals 2 times the sine of x, 12/13 times the cosine of x, negative 5/13. I multiply that out, and I get negative 120 over 169. Cosine of 2x. I'm going to plug into this formula. 1 minus 2 times sine squared, 12/13 squared. And I plug this in, I calculate this out, and I get negative 119, 169. And then I'm going to say that tangent 2x is sine x over cosine x minus 120 169 divided by negative 119 169. Divide by a fraction, I flip this one and multiply, so I end up with 120 over 119 for my tangent of 2x. So this idea, drawing this triangle, that's an important one. That will keep coming back as long as you do anything with math. Drawing a triangle using the sides of this code. All right, questions on that problem? Okay, our last set of formulas, half angle formulas. These all come from the double angle formulas, because doubling and halving are essentially the opposite things. So I'm going to start with cosine of 2u equals 1 minus 2 sine squared u. So these all come from these double angle formulas for cosine. Is u half of 2u? Yeah? So I could rewrite this as cosine u equals 1 minus 2 sine squared of u over 2. So u is twice u over 2. Yeah? So this is just rewriting the double angle formula in a little different form. And then I solve this equation for sine of u over 2. So I get sine of u over 2 by itself. When I rearrange and I do the algebra there, I get the sine of u over 2. I get a square root, and I'm going to say plus or minus because I have to take a square root. Square root's going to undo that square. The sine of u over 2 is 1 minus cosine u over 2. And we pick the plus or the minus depending on which quadrant our angle is in. So there's our first half angle formula. These don't come up quite as often as the double angle formulas, as this formula, but they do show up. And I'm going to do, yes, Vicki? Okay, you just, all right. And then let's look at the other double angle formula. Cosine of 2u equals 2 cosine squared u minus 1. I'm going to use the same idea that we did to rewrite this and say that the cosine of u equals 2 cosine squared of u over 2 minus 1. Rearrange this, solve for the cosine of u over 2. And I get the cosine of u over 2. My half angle equals plus or minus, because I had to take the square root, 1 plus cosine u over 2. So there's our second half angle formula. And then the tangent, the half angle formula for tangent comes from putting the sine of u over 2 over the cosine of u over 2 and simplifying. So I can say that the tangent of u over 2, and we actually get two that are the same. 1 minus cosine u over sine u, and that's the same as the sine of u over 1 plus cosine u. And this comes from putting sine of u over 2 over cosine of u over 2, and then simplify. So all of these, I would write all these on the board during the test. And again, these don't show up quite as much as these two, this formula and this formula, but they do show up. You do see them, and you do use them. All right, questions on where these come from? Okay, I just want to show you one example of how we would apply a half angle formula to help us do something. Find the exact value of cosine of 165 degrees. So the fact that it says exact value should be a clue that this has something to do with a unit circle angle. So how can we relate 165 degrees to some unit circle angle that we know? And the fact that we just talked about a half angle formula might give us a hint that this has something to do with a half angle. (165) is 330 divided by 2. So we're looking for the cosine of 330 over 2. And then we just plug this into our half angle formula for cosine. So I'm going to say the cosine of 165. What quadrant is 165 degrees in? Second. So our sine plus or minus for cosine in the second quadrant? Negative. Cosine is negative. X coordinate is negative in the second quadrant. So I'm going to get a negative square root of 1 plus cosine of 330 degrees over 2. Cosine of 330 degrees. 330 is 360 minus 30. That's the angle. So what's the cosine of that angle? Cosine, it's a square root of 3 over 2. We're talking about 30 degrees, so we're talking about the long side of the 30, 60, 90 triangle. And the 2, this has to be a bigger square root. There we go, 2. If you wrote this as your answer, you would be fine. That would be fine as an answer. If we wanted to simplify it a little more, I'm going to add these two fractions. So 1 is the same as 2 over 2. This minus the square root of 2 plus the square root of 3 over 2 over 2, which is minus square root of 2 plus square root of 3 over 4. And I can take the square root of that 4, and I get minus the square root of 2 plus square root 3 over 2. But this would be fine as an answer. Yes?
How many things do like what we learned yesterday? How many things do like 120 plus 1 plus 45 and then do it from like diagonally doing it yesterday? Yeah, I don't know how to, I know how you do that, but I don't know how to answer something.
So it would take some work, but we could show that they were the same. I guess the reason to do it this way would be if the problem said use a half angle formula, or if you recognized, before you recognized the other pair of angles, If you said, oh, 165 is 330 divided by 2, I can use a half angle formula. But unless the problem specified, you could do either one, and you would be fine. Okay? So just an alternate way of doing it. But it is kind of strange how they come out looking so different. Yeah. All right, questions? All right, the homework tonight, just some practice using these things. So, all right, there you go.